Thank you very much, Andre. Thank you for having me. I'm going to try to share my screen and we can then start the presentation. Can you confirm, Andre, that you can see my screen?
Yeah, I can see.
Okay. Um, we're going to talk about cloud native applications. More particular, we're going to talk about the role of functions in cloud native applications. I'm going to tell you about how to make your cloud applications function for real by giving you a complete overview of Oracle Functions as a Service. And you probably know we'll be talking about serverless, and we have this picture of on-demand peak request handling. And I'm also going to talk to you a little bit, to tell you a little bit more about what's really behind this. You have the mental picture and you have the physical reality. You should be aware of that because it will help you make better use of the service and implement your functions in a smarter way. These slides are available at the bit.ly address that's shown below. Actually, it's a bit longer than that. I will show you the full address later on. And now we go a little bit about myself. My name is Jellema, and I'm coming to you from, unfortunately, one of the hotspots for COVID-19 right now, the Netherlands. We're not doing very well. I am CTO for Amis. I've been there for 18 years. Before that, I've worked for 8.5 years at Oracle as a consultant for custom development. And I'm still in custom application development. I also go to customers, and then I will call myself a cloud solution architect. I've been an Oracle Ground Ambassador for maybe 4 or 5 years now, and an Oracle ACE Director for much longer. You see my contact details below. There are traditional applications, and traditional applications are the applications we've been developing for 25 years and are still developing, of course. And these are applications that we now tend to call monoliths, although they could be microservices as well. They consist of your custom code, of a combination of third-party libraries and frameworks that you throw in. They will implement a UI, they will implement an API, which we used to call services. It's basically the same thing. And these applications will run on against some form of data persistence, typically. In our case, usually an Oracle relational database, could be another database as well. And these applications run on top of some form of application runtime platform. That could be the Java EE uh, platform that itself is running on top of a JVM, on top of an operating system, on top of some hardware. It could be another runtime platform as well for Python or for .NET or for Node. But we will also always have a stack similar to this one. And in this runtime application serving stack are facilities like the ones listed on the left side of the slide. And now we're moving to cloud native applications. And what do they look like? Well, in cloud native applications, the focus is much more on the functionality that we need to implement ourselves, the functionality that makes our organization stand apart from other organizations. And we focus much less on all the things that are not specific to our organization. We hide them away or we leverage them as out of the box services. So in this case, we've got two functions and a web app. These apps can still be around, but we will drift towards functions much more. These functions and web apps can still have state, of course, but they don't leverage a single enterprise, all-encompassing database, but they will have their own data store, which will be uh, very much their own. It will be a private data store, and it can be created using a managed cloud service, an autonomous database, or a managed NoSQL database, for example. And our functions are running on this PaaS layer. And underneath the PaaS layer is an IaaS layer with infrastructure that we typically do not need to know anything about. We don't want to concern ourselves with infrastructure because that's generic. That's certainly not specific to our organization. And PaaS, to a large degree, also is generic. We also need to configure it in a specific tailored way. We don't have to install it or implement it or maintain it or manage it. And our application then makes use of a number of these PaaS services, for example, a content delivery network and a web application firewall, an API gateway to handle requests and route them to our functions, an event hub to connect our functions in an asynchronous way, a container engine, in this case, to run our web app, because that's not a function, that's something that's running continuously. More about that in a moment. And there are some other facilities that from a PaaS provider we get out of the box. We only need to configure, and we can easily integrate with the bits and pieces of functionality that are specific to our organization. And those are the functions. We also can leverage a number of facilities from our PaaS provider that help us do the operations, to help us monitor, to implement alerts and notifications, to do logging, and to do dynamic scalability. And here are some of the other aspects that we request from cloud native applications. We've come to expect from cloud native applications. That's what makes them interesting. All so that we can focus on our specific functionality that we can implement in functions, and how these functions are run, where they are deployed, how they are scaled should not be our concern. That's what we are after. That's what functions and functions as a service is promising us. So focusing on some of the characteristics of cloud native applications, they're modern, which doesn't mean a thing. They're born in the cloud and the cloud era, which still doesn't mean all that much, but they have an emphasis on the interaction and also on decoupling, especially on the interaction point, but not on the implementation that's underneath or behind that interaction point. It's basically encapsulation, but in a slightly new word. So between our custom components, we'll use APIs for synchronous interaction and events for the preferred asynchronous interaction. We also have interaction from our custom components to this out-of-the-box PaaS services. Um, we'll have less emphasis on how these PaaS services are implemented. It's more important that they provide us with industry standard APIs. I'm not going to go into too much detail here. And we want to focus on custom code that we deliver in small, simple units, because large applications are the bane of our industry, is something that we really cannot handle. We don't want to concern ourselves with explicit infrastructure. Of course, it needs to be there, but we don't want to know about it. It should be taken care for us. We want to think in terms of statelessness and in terms of dynamic scalability. We want to only pay for what we use and not buy big boxes and buy big licenses for things that we may not use, or at least not use all the time. And we want to have a lot of automation, no hands on the acceptance test environment and the production environment. So we get speed, we get repeatability, we get dynamic adjustment, and we get control. We don't make human errors. And of course, we make human errors, so we need to automate. And we want to consider our infrastructure and platform just as code and application. It's all software defined as infrastructure as code, or rather the infrastructure is code. And it should go through the same automation pipelines as we have our application coding. So if you focus on a number of key themes on this slide: modern, small, simple units, serverless, stateless, scalable, pay-per-use, and automated, those are probably the key characteristics of functions. That's what functions is doing for us, is getting us. So what are functions? Well, they are the worker bees, hence the graphic on the slide. They're typically small. They don't need to be small, but ideally they are small, stateless execution engines that handle one request or event, and then they are done. And they can do almost anything any regular application can do, but they don't have a lot of time to do it in. So a few minutes is the maximum time allotted to a function to handle request or an event. And ideally, it's much shorter. And no, you pay for the time a function is running for. The functions are serverless. They are deployed by us as developers, and then they are executed in some abstract, fully managed environment that automatically handles scaling. We don't need to know anything about that environment, not where exactly where it is what service it contains, what the CPUs are inside those service, what the size is of the service, what the network is like. It's all taken care of us for us. We as DevOps team, we do not need to configure VM service and network. We do not get to configure VM service and network. They're out of our sight, hidden away, encapsulated. We pay per execution and not just the number of executions, but also the duration of the execution and the resources required for the execution. And we'll talk a little bit more about the shapes available for Oracle functions. So the functions really are the glue and the worker bees in the cloud environments. And they take care both of application functionality, things the business cares about, and the operation side of things. So they handle much of the automation of our operations. And in the end, the business cares about that too, but they don't really realize that. So how are functions implemented? Well, they can be implemented in almost any programming language. And certainly with Oracle functions, you can really pick and choose any programming language you like. Some are more explicitly supported, but still you can take anyone. They are frequently, not necessarily, but frequently backed by Docker containers. If you see it or if you don't, they are typically there. Usually functions can be parameterized after deployment through configuration settings that translates to environment variables, and functions typically can leverage a number of cloud facilities, such as logging, monitoring, auditing, authorization, while you see the list. Now, Oracle functions, how's that done? First of all, Oracle has selected Project FN and even acquired the company behind Project FN for its function implementation. Now, Project FN itself is open source and you can use it anywhere. I'm going to show it running on my laptop. You can use it in any cloud environment, in any on-prem environment, and Oracle uses it inside its OCI cloud environment. So Project FN, once again, open source, available anywhere, and also at the heart of Oracle functions. I'll talk about Oracle functions in a moment. First, FN. So the container native serverless framework. It's open source, it can run anywhere, and it leverages Docker containers. So underneath your function is a Docker container or a Docker container image, and it will be a Docker container instance when your function is running. The starting of Docker container instances is handled for you by Project FN. That's part of the serverless notion. Yes, there are Docker containers and they're running somewhere on a computer, but you do not need to take care of that. You do need to actually know it. So Project FN has out-of-the-box support for several runtime languages, such as Node or JavaScript, Java, Go, Python, Ruby, and I thought Rust as well. I'm not sure about that. But it also allows you to bring your own Docker container images. So you can implement anything you like in a Docker container and bring that to Project Event to turn it into a function that Project Event then can start when a request needs to be handled. Project Event comes with a server and a client. Client is a command line interface. That client is used both locally against your locally running server as well as against the Oracle Cloud environment for Oracle functions. So what happens at runtime? Well, you have implemented your function by writing code in a programming language you know. You have given it to Project Event to turn it into a Docker container image. That's the build process. And then at runtime, your container is registered with the Project FN runtime environment. Project FN adds the function development kit and has this runtime function as a service framework. Now, when a request comes in, an HTTP request with a method, with headers, with query parameters, URL path, and of course the body, this request is received by Project FN, and it determines based on the request what function should handle the request, and then it will make sure that there is a Docker container instance running to handle the request based on your image. Your function then, so your code gets two input parameters. One is called input, or you can call it anything, but by convention it's called input, and it contains the the body from the HTTP request. You also get a context parameter, which contains a lot of additional details about the HTTP request itself. And then your code can do its thing, can handle the request, and in the end produce a response that's returned to the invoker of the function. The only thing you need to focus on is the function that sits inside that Docker container. And I want to show that in a very quick demo. We are rather short on time, so I will first explain the demo, then actually show it. So I'm working on my laptop. It's a Windows laptop. I'm running the Windows subsystem for Linux too. I'm running Docker Desktop, and I'm running Ubuntu inside the Windows subsystem for Linux. I've installed fn, which is extremely simple to do, and I've also got Docker running already. So the steps I'm going to go through is, first of all, to start the fn server, to have fn function as a service framework running locally. Then I'm going to create an application with fn. I'm going to the fn server will then know about this application. I will then create a new function. I will instruct fn to create a function with the runtime node. Of course, I could have picked Go or Java or one of the other ones. I'm then going to edit the function. I'm going to deploy the function to the app. At that point, the function is registered with fn server, and in the local Docker container image registry, a image is registered for my function. So this image now contains both what I have written in terms of code and all the other things that are required by the fn server to run this container as a function when a request needs to be handled. When I then invoke the function, a request needs to be handled. In the Docker engine, a container is started based on this image, and this container is then handed the request to handle. Okay, so that's the demo I'm going to show. And in order to not mistype, I'm just going to, I have already prepared the application. It's called the Hello app. And I'm going to type, oh, I should also show you that I've started the event server is running in the background. Event init. I think there already is a function called hello, so I'm going to create hello too. Three files have been created, and the only one I'm really interested in is func.js. Of course, if I'm going to create a function that requires additional npm dependencies, I'm going to have to edit the package.json as well. For now, let's just open the func.js. Here's the code that has been generated by default by fn at the time of initializing the function. Here I am adding some code to make it non-default, and at this point I have created my function. Let's assume that's what I've done, and now I'm going to fn deploy it to my app, which I believe is called hello app. My function is taken. Okay, I should have set my local context. I'm going to make things too complicated by continuing with the live demo. So I'm afraid I'm going to have to continue with the slides. Here you see the two important files that were generated when I created the function just now. So there's on the lower right-hand side, there's the func.js that contains the actual code of the function. This is what is generated by default. And the part of the code that is indicated by the bracket, that's the code that is actually mine. So the fdk.handle, that's the boilerplate required to hand my function to the event framework. The code within the bracket, that's my custom code. And of course, from this bracket, I can call into additional modules that can be quite complex. It doesn't need to be a functionality that just contains 5 lines of code, obviously. The func.yaml file is a file that's used to instruct the event framework about the function. It specifies the name of the function, the version and the runtime, and also what's called the entry point, how to run the function when a request needs to be handled. In this case, because the runtime is Node and the function is implemented in a file called func.js, the entry point will be Node func.js. So there's the metadata for the event runtime, and here's the actual implementation of the function. I could also have created a function in Java, and then these files would be slightly different. Well, actually, the func.yaml is slightly different. The implementation, of course, is very different. This is Java. And in this case, there also will be a Maven POM file with all the dependencies. For anyone doing Java development, it's completely natural to program Java classes, obviously, and to have a Maven file to define dependencies. So this feels like a very normal Java development environment. Now moving to Oracle Cloud. You are all aware of Oracle Cloud Infrastructure, I'm sure. Oracle has 2 pillars, if you like. One is infrastructure, and infrastructure also contains what we would call PaaS. So the name infrastructure perhaps is not all that well chosen. And then there are the cloud applications, the SaaS part of Oracle. That's where the Fusion applications are, where many other applications are. That's not where we are, because we are on the left side on Oracle Cloud Infrastructure, where we will be creating our custom applications using functions. So what about Oracle Cloud Infrastructure? It's the Generation 2 cloud, and we probably all know that Generation 1 Oracle Cloud was not a big success. Oracle Cloud Generation 2 is doing much better. Its main themes, well, attractive pricing, secure by design, open, so not proprietary technologies or not only proprietary technologies, and if there are any, open them up by public APIs. Enterprise grade technology. You all know about the free trial, but to be honest, with Oracle functions, you don't really need the free trial because the functions themselves have a large free tier and are pretty cheap anyways, unless you have real intense usage. So Oracle functions, as I mentioned before, they're based on Project FN. And I've explained about Project FN. On Oracle Cloud Infrastructure, what's added to vanilla Project FN? Well, to be honest, we don't really know because that's part of what's happening inside OCI. But there is an interaction with some form of container platform that knows how to run, of course, but also how to scale and how to scale out to additional physical nodes. But it's all taken care of for us. OCI handles requests, and OCI provides additional PaaS facilities for operations like monitoring and logging, and we'll talk about that in a moment. The function container images on OCI are stored in the OCI container registry. Triggers for function execution can be an HTTP request or an event on OCI, more about that, and I mentioned monitoring and logging. So hopefully I can make life a little bit better than in my previous attempt at demo. We are now going to work against OCI. So instead of working locally, I'm going to use the context, OCI context. And I'm going to not deploy to hello app, but to fun app. And fun app is an application I've defined before on Oracle Cloud Infrastructure. So at this point, you see the function container image being built. And when it's built, it's pushed to the Oracle Cloud container registry. And the function is registered. And I will show this in a slide in a moment. And at this point, the function exists and can be invoked. So fn invoke fun app, and I called the function, what I call the function hello2. Always getting a syntax. And now you will probably notice it takes, oh, didn't take as long as I expected. You have the cold start, and I'll explain about the cold start in a moment, but it takes a little time for a function to become executable, because based on the Docker image, a container needs to be started, and that takes some time. So all these invocations went against Oracle Cloud. And I'm going to show you on Oracle Cloud Infrastructure what exactly that looks like. So I'm assuming that you've all been here, and if you haven't, you should give it a try. It's free. Under developer services are the functions, and under functions is function app, and under function app now is function hello2. So this is the function that was just deployed, last updated today, UTC time, and I can see the invocations. There were 5 invocations in the last minute. What else? I can see the duration of the invocations. They took on average just under 300 milliseconds. After a large number of invocations, this average duration will probably go down a little bit because the effect of the cold start is taken away. If I return here and do some additional invocations, they should soon show up in the metrics section. Under configuration, I can define the environment variables that should be injected into my container instance at runtime. So this is how I can configure a function after deployment. The same function definition can take on different functionality in different environments or at different times because of the configuration settings. I can also specify not at the function level, but at the application level. Let's return to the application level. I can specify that I want logging to be taking place. It's already set up for this application. So here I've specified I want to enable logging, and I want to send my logging for this particular application to a specific logging group and grouped under a specific log name. And we don't really have time to go into the logging service. It's fairly new. It only exists since the beginning of September, and it allows a fairly advanced, or maybe common, but a fairly advanced way of consolidating logging from all different kinds of services on OCI, taking them together and searching them through them in a sort of elastic search way, if you know what I mean. So the demo you just saw was I've switched to the context for OCI, and in this context I've specified the configuration details for my cloud tenancy. In this OCI context that I'm using, I've specified the compartment ID. I've specified the API URL for deploying the function, and I've configured the container image registry. And based on this information, I was able to log in to this container registry, and creating the app At this point, I'm connecting my application, which is a logical concept, to a subnet within a VCN, and this subnet is tied to a specific region. So at this point, I'm connecting my application and my functions to a specific region somewhere in my Oracle Cloud tenancy. I've created the application. I have created a function. At this point, the function isn't really connected to the application, but it will be when I deploy. Again, I added the function. I then deploy the function to the application. And because the application is connected to the subnet and the current context is my OCI tenancy, this deployment action will actually mean deployment against the tenancy. So locally, the container image is built, but then it's pushed to the Oracle Cloud Container Registry. The application is defined on OCI, and the function is defined on OCI, and the function refers to the container image. And I probably didn't show that before. But here you see the, the reference from the function to the container image on the registry. So when I now invoke the function, as I was doing before, I'm asking OCI to handle this request to a function. OCI knows about the function, but there is not yet a container running. So based on the container image in the container registry, a container instance is started and the request is sent to the container instance to handle. And I get my very fancy result. So this basically is what we saw happening just now on OCI. This is what the container registry looks like, and this is what the list of applications looks like. I've already shown that. In the application, you get an overview of the functions, and for each function, you get an overview of the metrics, and of course, of the configuration parameters. So in terms of how does this work on OCI, what's the logical structure? Well, the functions live inside applications, and of course, anything on OCI, and there can be multiple applications, and each application can have multiple functions. The limit, by the way, is 20 applications in a tenancy. I'm not sure why there is this limit. The application itself is a fairly innocuous construct, but there's the limit. Everything exists, of course, inside a tenancy, and inside the tenancy, we have compartments, and everything lives inside a compartment. In the compartment, we have a VCN, and in the VCN, we have the subnet, and the application is tied to the subnet. So this is where it all comes together. And we also have the container registry that doesn't really live inside a specific compartment. And we have groups and policies to allow functions to do things and also to allow developers to work with certain functions and not work with other functions. So the mental picture we have is it's both stateless and serverless. And that's a fine mental picture, but it's good to know that it's neither. It's neither stateless nor serverless. So what is it? The mental picture and what's real. So mental picture is we program some logic in one of these programming languages or even another programming language. And then we add the function development kit, and that together is our function. And yeah, we know there is something with Docker. There's a Docker image, and we don't really care too much about it. That's too technical, too specific. We like to focus on the thing that's on top. And then we also know that by the time we want to run the function is combined with this Docker image, and then we add some configuration parameters at runtime, and then we can run the function and do the thing the function is meant to do. And that's true, but then there is a little bit more to it. And it's good to know about the thing that's also to it. So there's the build process. And in the build process, we take our code, our logic, but then we add an operating system, and we also add a language runtime, and we also add the FDK, and all of that put together, that's the function container image. And that's, of course, the starting point. And this container image is pushed to the image registry. So now and there's the function.yaml with the metadata about the function. when we deploy our function, what we're basically doing is handing over to the Oracle Functions Framework on OCI. We are handing over our container image for the specific function and also the metadata. And the metadata consists not just of an instruction of how to run the function inside the container, but also what the shape is, the memory shape of our function. So by default, our functions will run in a physical constrained environment with 120 megabytes of memory, and for many functions that will be plenty, but you can specify larger shapes. And here's our first indication that, of course, it's serverless, but not entirely free of physical details. So let's look at what actually is happening at runtime. So a request arrives, and at this point, based on the container image, a function needs to be instantiated. And that's happening, well, by starting a Docker container instance. And this container instance is injected with environment variables, and then it can do its work. But of course, this container instance is running on some form of container orchestrator. And of course, the container orchestrator is running on a VM, and the VM is running on a physical server somewhere. So the reality is not serverless. And again, the mental picture of serverless is fine, and we can work with that, but it's not entirely true, of course. So we've got various memory shapes, and along with the memory shapes go file system sizes. So yes, our function has a file system, and we can write to the file system, we can read from the file system. And as I said, the configuration parameters are available as environment variables. So now the request can be handed to the Docker container instance, and the Docker container instance can handle the request and can leverage, as you can see, the operations facilities on OCI. And it can then, of course, return the request. And at this point, if the function is done handling the request, can it just go away? Well, our mental picture was that it does go away. It's stateless, so it will handle a request, and when it's done handling the request, it goes away. That's not the actual truth. So the actual situation is that after handling a request, the container instance, a function instance if you like, but it really is a container instance, will stick around. And it will stick around for 10 to 15 minutes. So it stays hot for handling more requests. And that's why our first request to a function can take some time, up to 15 or 20 seconds. But any additional request, if it doesn't come after 10 to 15 minutes, will also be rather quick because it can benefit from this already started container instance. Only when the instance has been idle for 10 to 15 minutes will it be removed. During this time, and this is important to realize, during this time, it retains its state, its global state, and also the contents of its file system. So you can use this knowledge that it will stay around if the function keeps on being executed. You can use this knowledge to hang on to expensive resources, such as connections. If your function writes to a database, do not create a new connection on every execution of the function, but check if your connection is still available in the global state, which typically will be the case for fairly hot functions. So this is important to know. The mental picture is it's stateless. The actual reality, it's not, and that's a good thing. You can benefit from it. Of course, you can also shoot yourself in the foot. So it's not stateless either, not serverless, not stateless. What's the world coming to? If there are additional requests, they can be handled by the same container instance. Additional request, same container instance, another request, same container instance. However, the function instance or the container instance will only handle subsequent requests, but not concurrent requests. If there are concurrent requests, then OCI will start another instance of the container for handling those other requests. And this other container instance could be on the same server, could also be on a different server. And we don't know, and we shouldn't care. It's not up to us, and we really shouldn't care. What you probably should know is that Oracle Functions can keep on starting container images up to 30 gigabytes of RAM for the entire availability domain. Now you pay per execution and the memory used in an execution. You don't really need to worry whether there are 2 instances or 200. You don't pay more. And it's important to know that you don't pay for idle time. So I've done a little bit of investigation into what's the physical reality versus my mental picture. And I've discovered, if you like, that it's not stateless, it's serverless. There's a state across executions, and an instance, while it's idle, will stay around for about 10 to 15 minutes. Do you get any concurrent request handling? No, you do not. Can you get at the container details? Well, to a certain extent, the container identity, so you can tell whether requests have been handled by the same container or a different container. And there's one additional aspect that might be interesting. And so my findings, no concurrent request handling. And this is a picture taken from the logging service. And the logs have been grouped by host, and clearly 4 different hosts for 4 concurrent requests, not concurrent request handling by the same instance. Each instance can handle multiple requests. State is kept between requests for about 10 to 15 minutes of idle time. And this one is interesting too. After the request has been handled, your instance will be able to perform another 14 seconds of work, 13 or 14 seconds of work before the instance is paused. So you receive a request, you respond to the request. As far as FN is concerned, you're done handling the request, but you can perform an additional 14 seconds of work in the background before the container is actually not available anymore for handling work. And I'm not sure whether this is part of the pay-per-use, and I'm not even sure that I'm supposed to know about this, but it's something you can find out yourself easily. An instance is killed, as I said, after approximately 10 minutes, 10 to 15 minutes. It seems to be 10 at the moment. What about pricing? If you don't use functions, you don't pay for functions. If your function is idle after it has been used, you don't pay for that idle time. Your first 2 million invocations, just by counting invocations, are free, and then you pay a little tiny little bit per function invocation. Slightly more important is the execution time pricing, where you pay for the multiplication of the time it takes your function to run and the memory used by your function while running. And also here you've got a lot of free tier. So the first 400,000 gigabyte memory seconds are free. And for getting started, for many use cases, that'll be enough. Especially for anything with operations and automation, you will never get, not quickly get to numbers such as these. Now it's 9:45, and I know I'm supposed to stop at this point. I do have some additional slides to go through, so if no one is stopping me, I will keep on talking, and it will be captured by the recording if you're not able to stay. So very quickly, how do functions then compare to containers, then compare to VMs that you can run on OCI? Functions, of course, the mental picture is serverless. You don't need to do DevOps on IaaS. You don't have to do any administration on where the functions run, where they are deployed, where your servers are, what the network configuration is, etc., etc. And you have stepless pay-per-use. Pay a little bit more, use a little bit more, pay a little bit more, and this large free tier. Then there's the auto scaling that you don't have to worry about. You've got automatic failover, and you've got a very good integration with OCI. I'll talk a little bit more about that. You have a slightly restricted programming model. Well, actually, it's fairly restricted. The function needs to do its work within 2 minutes. It is somewhat restricted. Then when you run containers, there's a lot of more physical detail, infrastructure detail that you need to concern yourself with. It's all standard Kubernetes. So there are many resources to benefit from, and you pay per VM. Whether you're using the VM or not, you pay for the VM and you scale per VM. So it's not a tiny little bit of scaling that you get with functions. It's fairly crude in comparison. If you have huge volumes of work to be done, and it's fairly constant, no peaks, or even if you have some peaks, containers might be better than functions, but functions, as I said, is more cloud native, requires even less consideration of administration activities, infrastructure operations. Of course, you can also go for normal VMs, not even containers. Then you have even more work to do yourself, but you also have even more freedom. You're much more flexible, even more flexible with your programming model than with containers. So no silver bullet solution, of course. The integration with OCI, a function execution can be triggered, as we've seen, from Fn and from an authenticated signed HTTP request, which is kind of hard to make. So it's probably easier to make requests through the API gateway. Functions can also be triggered by events, cloud events on OCI, by notifications. And notifications is like a pub/sub mechanism. And we can use this also for asynchronously triggering functions from functions, as we'll see in a moment. One example of notifications also are alarms from the monitoring service. And then there's this new concept of a service connector. For the moment, it's only available for connecting the logging service to a function, but I suppose there will be additional connections possible from OCI services to functions. Functions can also be invoked from a Terraform plan that we can use through the resource manager. And we can use a monitoring health check that can be scheduled to call through the API gateway to a function. Now, in terms of operation activities and actual functional application implementation, you could say that the purple indicated arrows, trigger points, are on the application side, and the yellow ones are on the operation side, just to give you an impression. Of course, you can decide for yourself how you like to call this. The API gateway, I mentioned it. It's still a fairly new service on OCI, beginning of the year. It's a crucial service on OCI. It's the entrance point for any service invoker, either inside of OCI or outside of it, for invoking endpoints, HTTP endpoints inside OCI. The API gateway, you could consider it a very, very, very lightweight service bus, but that really is the wrong comparison. But for people who know a service bus, it helps a little bit. It does authorization of requests, routing of requests, load balancing of requests, mapping of the incoming request to the onward sent request. It can, since September, also do transformation of the parameters and the headers in the request. And it also performs a number of observation tasks. API Gateway has three types of backends. A stock backend, which is basically also always returning a static response, almost like a mock. It can invoke any third-party HTTP endpoint or an HTTP endpoint somewhere on OCI. And then the third one, which is relevant to our discussion today, it can invoke a function as well. So the easiest way to invoke a function from outside of OCI is to go through the API Gateway. And the API Gateway will perform a number of additional functions. So on API Gateway, you configure an endpoint. In this case, the endpoint is /gb/summarized tweets. That's the external URL, at least part of the external URL, as you can see at the bottom of the page. You specify which HTTP methods will be handled in this route, and then you specify the endpoint. And the endpoint in this case is of type Oracle Functions. And then I've specified the application, which is called lab1, and the name of the function. And this is all the setting up I require for a simple routing from external HTTP requests arriving at the API gateway to the function. And of course, the function is handed the URL parameters as well as the body content that the API gateway receives from the external invoker. So from functions, you can also call out to OCI services. So our function can, of course, itself call out to API gateway, and through API gateway can call to other functions in a synchronous way. You should try to stay away from synchronous calls from functions from an architectural point of view. It's not very decoupled, but of course it will work. Ideally, if you have to invoke another function, you can trigger it via a notification. So that's the pub sub I was talking about. A notification can also, for example, send emails, but it can also trigger functions. So here we have the asynchronous loop from function to function. Other OCI services that you could easily leverage from functions include streaming. Think Kafka, but it isn't. It's OCI streaming. The object storage, the autonomous database or the NoSQL database, and the vault, for example, for retrieving keys and secrets. Of course, as I mentioned before, functions leverage logging, monitoring, and auditing facilities on OCI. In order to allow a function to make calls to OCI services, well, the function needs to identify itself, needs to have a private key to call to the service. But there is a specific mechanism, and I don't have time for the details, but you should be aware of it. It's called resource principal authorization. And basically it means that through defining a policy on a dynamic group that includes the function receives permission to call out, to perform operations against OCI resources, such as calling out to the object storage service. And if this policy and this dynamic group have been defined, the function, when it's deployed on OCI, will have a private key file and a second configuration file injected to it and available in the function. Again, I don't really have the time. This is something that you should be aware of if you're going to create functions that invoke OCI services. So here's an example I took from the Red Thunder blog. It's for implementing a specific operations task on OCI. It's about getting the data from the audit service. It's retained for 7 days. If you want to retain it for longer, then you would have to get it out of the audit service and store it, for example, on object storage on OCI. And that's described in this blog article. The architecture picture looks like this. A health check is created to make an HTTP call on a schedule every 15 minutes, for example, to API gateway. API gateway triggers a function. This function, which has been set up with resource principal authorization, calls out to secrets to get a key, and then calls out to IDCS to retrieve the audit events. And then finally, it writes all the audit details to object storage. So this is a nice example of a solution design with functions at the very heart to perform an operations task on OCI. Testing of functions is not very different from testing of any other code. Of course, you should have tests, unit tests, as well as integration tests, as well as smoke tests. And in order to test your function code, it's best to mock the FDK. So you can do the test using your favorite testing framework. Mock the FDK, so you can test your function code in isolation, but also test the interaction of the behavior of the FDK with your function code. And of course, but that's not special for functions, you should mock external services during a unit test. Of course, there are other types of tests that you should take care of, integration tests, and I particularly like smoke tests. Smoke tests to run in any environment, and not just after deployment, but periodically, to ensure that your function is still running. And the main thing you're testing then is that all the connections and dependencies on other elements are still okay. So this is what a smoke test for a function should probably looks like. You define the smoke test, and through the API gateway, you make a call to the function, and the function then will call out to all its external dependencies. CI/CD for functions. You develop your function as you develop any kind of code. You commit it to Git, and this will probably trigger the continuous. This is part of the continuous integration. You will then start an automated test, for example, using Jest for node application, adding all the NPM modules, running the static code analysis, using Jenkins for organizing, coordinating all of that, using the event CLI to perform the build of your function, turn it into a container image, push the container image to the container registry, and this you might say ends the continuous delivery. Then, of course, if you want to deploy, and this can also be done in an automated fashion, you can do it using the event CLI, as we've seen before, or you can, and then create the application and the function, or you can do it using a Terraform plan that can also read a function definition and the container image for the function from the registry, and then push it, deploy it to OCI. This is also supported inside Oracle Visual Builder Studio. And that's where the Oracle Developer Cloud Service has now been integrated with the Visual Builder, and that's called the Visual Builder Studio, which has facilities for CI/CD. I've mentioned these facilities before. I'm not going to discuss them again. I haven't shown you logging. I've shown you where the reference is to logging. The logging service itself has a UI similar like this one, and anyone who's ever seen the Elastic Stack will probably think that's similar, and indeed it is similar. You can look through all the logging produced by any service on OCI, but in this case, of course, we are specifically interested in functions. So anything in a JavaScript function that's written to the console is captured by the logging service and is available for investigation in this UI, which is really convenient, and it didn't exist before, which was really inconvenient. You can then find your logging on the object storage, and then it just in the form of a JSON file, which was not very convenient. So you can drill down into details of each log entry, and you can do further investigation and analysis. And this, for example, is how I found out about the different function instances that were running to handle concurrent requests. I've mentioned the health checks. Not going to go into detail. A health check and monitoring is a check on the availability of an HTTP or TCP/IP endpoint, and you run this check on external cloud services, not on OCI, but on the other cloud services. This is something all taken care of by OCI, and it allows you to check whether your function, your endpoint is still available, and of course also what the response times are from anywhere in the world. You can use this to check your functions as well. Now, OCI does not support scheduling functions, and there are some tricks for still executing functions on some form of schedule. One way of implementing this trick is using the health check. So the health check can make an HTTP request once every 30 seconds, 1 minute, 5, 10, or 15 minutes. And then it can call an HTTP request through the API gateway that will trigger a function. You could, as a configuration parameter, specify a specific cron expression for your function, and inside your function, inspect this expression and determine whether or not to execute the function. This cron expression could also be passed as a header or parameter in the HTTP request. There's another trick that you could apply, and that is using the monitoring service. Define an alarm, for example, an alarm on the condition that if a function has not been invoked for 5 minutes, then something should happen. And that something that should happen could be the invocation, could be the publication of a notification that in turn will trigger a function. So this is another way of creating some form of crude scheduling mechanism. Of course, we're all waiting for Oracle to add a scheduling service to OCI, but it's not there yet. some points for improvement. The mechanism for calling a function from a function could be much simpler. Right now, you have to go through the API gateway. That's not so simple. And there's also not easy tracing of function to function calls. It would be great to have an asynchronous mechanism for function triggering. You can do it, but it's in a very roundabout way. It would be nice to have an orchestration across functions, similar to the durable functions framework on Azure functions. And actually, Project FN used to have FN workflow, but that's not FN flow, sorry, that's not supported on OCI right now. And Project FN itself does not seem to be a very alive project, given the activity on GitHub. So I would like Oracle to take a little bit more action here. To get going with functions, there are many resources on the Architecture Center, on GitHub, on the OCI documentation. And I would like to point out the live hands-on labs that you see on the lower right-hand corner. Here you can try out functions without having to install anything. Final slide. Functions, and thank you for still being with me. Functions are a crucial part and a great example of cloud native. I hope I've made that clear in this presentation. I've talked about cloud native and what the great benefits and the characteristics are of cloud native. Functions help us to achieve those benefits. So it's serverless in all the good ways, even of course it's not really serverless. It's simple and cheap. It gives you a lot of freedom of implementation. There's a little bit of lock-in, but you can basically use any programming language. Any Docker container can be turned into a function. It's very easy to get started with. It's very easy to get rapidly started with it. And there's a great native fit with OCI. So if you're on OCI already, there are many things on OCI that you can improve, make easier, make smarter, make faster, make cheaper probably by using functions. So I would like to thank you for your attention. I'm sorry for this huge run over. I hope I've added additional useful information. And the link to the slides and the sources are on this slide, the bit.ly link. So once again, thank you very much.
Thank you, Lucas. You have one question in the chat. Is there some sort of query language available for the logging service?
Yes, there is. I'm not quite sure what it's called, but there is indeed a query language both for the monitoring service that's called MQL, but there's also one for the logging service. It's well documented. I don't know. I don't know the exact name, but it is well documented.
That is it. Yes. Thank you very much for your time, and thank you for being with us on this tour.
Okay. Thank you. Thank you for your attention.
Bye-bye.
Have a great day.